Okay, welcome. Today's lesson is 65 applications using similar triangles. What's our objective? Get ready?
Applications using similar triangles.
Very good. Today we're going to learn how to use similar triangles to do a thing called indirect measure. We're going to solve some real world problems. For example, if you want to know the height of an amusement park ride or the length of a pond to see if you could swim that many yards but you're not sure how long it is, maybe how high a flagpole is, I'm going to show you a way that you don't have to take a tape measure to the top of a flagpole and hang the tape measure down. Or you don't have to take a tape measure across a pond swimming, to measure how long the pond is, but there's a cool way you can be indirectly measuring these objects. So I'm going to have Kaylee flip it to zone 4, hit the number 4. And I'm going to use, we're going to do a sun example, but I'm going to show you using our sun, which is our projector, and we're going to cast a shadow with our light source. So if I put this, maybe this represents a flagpole and the whiteboard represents the ground, and that's the sun. And let's say our sun is so far away that any object I place on my whiteboard, the sun has the same angle of shadow that it's going to cast. All right, so here's our flagpole, and notice our shadow's right here. It's about that long. If I hold up a longer object, it's going to have a longer shadow, right? Okay. So this long of an object is a meter stick. By the way, a meter stick is 1 meter long. Just keep that in mind. Okay, so look at its shadow. Could you say that the two objects that are casting shadows with the same light source that's super far away, we could even say theoretically maybe it's infinitely far away, so that there isn't any change in the angle. But if I took each of these objects and placed them perpendicular to the board, would their shadows be proportionate to the length of the object? All right. So in other words, if its shadow was, say, 1/3 the length of its object, should this shadow be 1/3 of its length? They should be a proportionate length, right? So any object I could put up there, if I knew the length of one of the shadows and said, hey, that shadow is 1/3 the length, so if I put another object, I would say, hey, that shadow is 1/3 the length, because it's proportionate. They cast the same angle of shadows, which creates similar triangles. So that's what it's about today. And Kaylee, you can say, flip it. You're going to flip the switch to off and then back on. That's the only way to reboot all the lights. Okay, question, Emma.
Isn't this what we did last year with the flagpole?
We did. We have one more lesson on this, and it's more in spring. We'll go outside, and we're actually going to do this. We're going to measure the shadow. So today, for our first example, we're going to take this indirect measure, that shadow that's cast by the sun. The angle is going to be the same angle as if I took something smaller like a 1 meter stick, which is 1 meter long. Just making sure. Okay? It's got the same angle here. And the angle that hits the ground is going to be the same angle. And they're both perpendicular to the ground, so therefore, the triangles are similar. We know similar triangles have proportionate sides. That's the giveaway, because if those sides are proportionate, because they're similar, I can set up a ratio or a proportion saying, hey, this length to its shadow is proportionate to this length to its shadow. I don't like the fact that these are different units, meters and centimeters, so I'm going to move the decimal over twice because there's 100 centimeters in a meter. So now that becomes 1.2 meters. And I'm going to write a proportion. What am I going to write? Get ready?
Proportion.
Proportion. I'm going to say pole to shadow is proportionate to meter stick to its shadow. As long as your units are the same here, you don't have to change. If this was in inches, as long as they're both in inches, it's okay. Solving for x, all I have to do is multiply both sides by 30. So we're going to do that. Times by 30. Times by 30. Do you need somebody? Yeah, she won't come in here until the next period. Okay. And then I get x equals 1 times 30 divided by 1.2, so really it's just 30 divided by 1.2. And who's got that typed into their calculator? Lisa?
25.
25, and we're in meters. Let's make sure it makes sense. 25 meters. If a 25-meter flagpole casts a 30-meter shadow, look, it's a little bit longer than the object. Is this shadow a little bit longer than its object? And it worked. It made sense. It's proportionate because they're similar triangles. Okay, this original proportion, does it matter which sides I put on top and bottom? Could I have said pole over meter stick equals shadow over shadow? I could. It's still proportionate. I could have said shadow over meter stick equals shadow over pole. As long as you are consistent in the which one you do first and which one you do second. You can pick any order is okay. All right, last example. And by the way, again, the point of this is it's not practical to climb up a flagpole and drop down a tape measure. So this is a cool way. When I was in high school, we had a math club day at Lagoon, and all the members of math club, and I was the math club president, go figure. We took our math club and we went and measured the height of Colossus by using, well, we did something like indirect measure, but we used math to figure out the height of it. So it's kind of a cool, fun thing to do. So say Josh is up camping with the scout troop, and the leader says, hey, Josh thinks you can swim across that pond. I said, well, we don't really know how far it is. And Josh said, well, I know I can swim 50 yards in the pool, but I don't know how long that is. So he says, well, what if we did this cool math experiment to find out the length of the pond without swimming it? So he says, well, if I can just make a smaller triangle that's similar to this bigger triangle, and if I know this length, I could use proportions to find out this length. So this is what he did. He marked a stake here and here, and then he marked his spot right here and here, and he measured out. And it ends up, if you keep reading, there's a lot of words here, but it's 45 yards from here to here. So then he just went 10 to make a smaller triangle, and he marked a stake there. And then he takes a string and he walks exactly parallel to the pond. And he's walking. And as soon as he notices that his starting point and his second point at the end of the pond is lined up in a straight line, he marks a stake there. Right? And he measures, and that's 8 yards. So we got 10 yards, 8 yards. First step in solving these problems is separate your two triangles and draw two different triangles and label them. You'll see the solution will appear before your eyes. 10 and 8, there's the small one. The big one is 45 and x. They're similar triangles, right? How can I write a proportion helping me to solve for x? What would my proportion be? What could it be? Joseph?
Like times 4.5.
You're already seeing a scale factor. I like that. You would times 10 by 4.5 to get 45. And you found that by dividing. Can we do it here? Yes, that would be another way to find this one. What's about the proportion? Kaylee, did you have a proportion for us?
Yeah, you just put x over 45 equals 8 over 10.
Okay, so you said the unknown to this length is proportionate to this leg to that length. And you kept in the same order. Vertical to horizontal, vertical to horizontal, in this order. And then we're going to cross multiply, or even better, faster, just times both sides by 45. We are left with x equals that. So it'd be 8 times really 4.5. Who's got that calculated out? Spencer?
36 yards.
36 yards. So I think Josh could swim it. What do you guys think? Totally. You never know if he can swim or not. And then does it make sense? So let's see, 10 and 45. This is like 4.5 times longer. Is 36 4.5 times longer than the 8? Yes, it's proportionate. It makes sense. Okay, so again, this is called indirect measure. What is it called? Get ready?
Indirect measure.
Indirect measure. We used similar triangles. We wrote a proportion and we solved for x, and that's all you have to do. So you get to now put it to the test on page 443 for your practice set. Trash.